main sources of sodium chloride is from the seawater, and seawater which consists of 2.7 to 2.9% by the mass of salt. Plain solution in the sense, it is a concentrated solution of sodium chloride which has been dissolved in very little quantity of water. Hydrochloric gas which makes sodium chloride to soluble in this gas, and we get the pure sodium chloride. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called S block element. Under that, we have discussed about the differences between lithium and other alkali metals, and also we have seen that the general characteristics of compounds of alkali metals, and we have discussed about the preparations and properties of some important compound. In that, we have deeply talked about the sodium carbonate. So, we will extend this some of the important compounds which we also used in our daily life. I'll go with the sodium chloride today, and we are going to understand what is sodium chloride, how do they prepare the sodium chloride, what are the uses of sodium chloride, we are going to discuss. And next, we are going to discuss with the sodium hydroxide and their manufacturing process by Kastler-Kellner process and the uses of sodium hydroxide. And we are also going to discuss with the sodium bicarbonate. In this compound also we are going to understand what is sodium bicarbonate, their preparation and their uses. Lastly, we are going to learn more about the biological importance of sodium and potassium. Okay. So firstly, I'll go with the sodium chloride. We all know that we are very much familiar with the sodium chloride because this is a table salt which we are using in our daily life to enhance the taste for our food. Is it right? Yes. So the main sources of sodium chloride is from the seawater, and seawater which consists of 2.7 to 2.9% by the mass of salt. Approximately 50 lakh tons of salts which has been produced annually in India by solar evaporation. So, we also know that the salt, whatever we are using in our daily life, which is obtained mainly from the seawater. So, how do they prepare the seawater? Let's see now. By using seawater, how do they prepare the salt? Let's understand now. The production of sodium chloride from seawater. NaCl is obtained from the seawater by the evaporation in presence of sunlight. So, once the seawater which is obtained, they will do the evaporation in presence of sunlight. The crude sodium chloride which contains sodium sulfate, calcium sulfate and calcium chloride and magnesium chloride as their impurities. So, if you have taken out the crude sodium chloride which also consists of many impurities, it may be a calcium chloride or it may be calcium sulfate or it may be sodium sulfate or sodium chloride or magnesium chloride, etc. To obtain the pure sodium chloride, crude sodium salt which is dissolved in minimum amount of water and later it is filtrated to remove the insoluble impurities. It is very, very important here. So, once you collect the seawater, they will do the evaporation. If you do the evaporation in presence of sunlight, you will obtain the crystals of sodium chloride. We know that this crystals of sodium chloride which also consists of many impurities. In order to remove these impurities, they dissolved in only minimum quantities of water and they will do the filtration process to obtain the pure sodium chloride. The solution is later saturated with hydrogen chloride gas. The crystals of pure sodium chloride will be separated out. The calcium and magnesium chloride are being more soluble than sodium chloride or remain in the solution. So, once you obtain the filtrate, we are going to pass with a HCl gas, that is hydrochloric gas. Is it right? That hydrochloric gas which makes sodium chloride to soluble in this gas, and we get the pure sodium chloride. If any impurities are there in the form of magnesium and a calcium chloride, it will be separated out. This is how from the seawater they will prepare the salt known as sodium chloride, and it is commonly known as table salt. And sodium chloride will be melted at very high temperature, that is around 1081 Kelvin. It melts at very high temperature and it has a solubility of 36 grams of salt will be dissolved in 100 grams of water at a normal temperature around 273 Kelvin. Okay. The solubility does not increases appreciably when you increase the temperature. When you increase the temperature also, the solubility of the salt in water will not be increased. These are the importance of the sodium chloride, that is nothing but the table salt, which is also known as what? Sodium chloride, along with the production. So, hope you understand with the production and the boiling point as well as with the solubility. We'll see with the uses now. So, we all know that sodium chloride will be tremendously we are using as a table salt, and which enhances the taste for the food, and it is also known as common salt or table salt for the domestic purposes. Not only we are using the salt to taste for our food, it is also used in the production of sodium peroxide, sodium hydroxide and sodium carbonate. Okay. Let's again, we'll recall with the production process so we can easily remember it. So, first what they will do, they will collect the seawater and they will do the evaporation. So, once you done the evaporation in presence of sunlight, you will get the crystallized form, or you can say that the crude sodium chloride will be obtained. Later, this pure sodium chloride will be dissolved with some amount of or minimum quantities of water to obtain the pure form and to eliminate the impurities. Once it dissolved, the impurities will be collected and the pure compound which is present on the filtrate, it will be collected later. To that filtrate, we are going to pass with the HCl gas to obtain the pure sea salt. Okay, this is how we can easily obtain the salt from the seawater. Next thing is, another important compound is sodium hydroxide, and it is represented as NaOH. Sodium hydroxide. It is also known as what? Caustic soda. Why it is also known as caustic soda? Because it has a corrosive effect. When we touch with our fingers, it will cause us a burning sensation. That is why it is named as caustic soda. Okay. Caustic soda or sodium hydroxide is one of the most important chemical in the industrial use, and caustic soda must be handled carefully because it is caustic to touch and causes a painful burn. Now let us understand how do they manufacture this caustic soda or sodium hydroxide by Kastner-Kellner process. By what? Kastner-Kellner process. The caustic soda is manufactured by Kastner-Kellner electrolytic process. During this process, here we use an electrolytic cell which consists of two electrodes. That is, we consider the brine solution, that is a saturated solution of sodium chloride in what? Which has been electrolyzed by using mercury as a cathode and we use a carbon as a anode. So, we are using two different electrodes, that is a mercury electrode and we use a carbon as a anode electrode. And we are using what? Which electrolyte we are using? We are using the brine solution itself as a electrolytic solution. Okay. Remember, brine solution in the sense, it is a concentrated solution of sodium chloride which has been dissolved in very little quantity of water. Okay. So, when you apply the electrical field, the sodium metal discharges the cathode and combines with the mercury to form a sodium amalgam. So let's see with the reaction now. Especially the reductions will be occurs where sodium will receive the 2 electron which is obtained from the chlorine to form 2 Na, and later the sodium atom combines with the mercury and forms a sodium amalgam. Okay. Chlorine, which also evolved at this anode in the form of gases, the chlorine will give us to 2 electron, and these 2 electron will be accepted by the sodium to form a 2 sodium molecule. Okay. So where it is undergoing oxidation, where our sodium which is undergoing reduction. The mercury which is containing dissolved sodium which is sent to the another chamber known as decomposer, where sodium reacts with the water and forms a sodium hydroxide and hydrogen. So once the sodium and amalgam, the compound which is formed, it will be sent to the another chamber called as decomposer. In that chamber, we are going to treat the sodium and the mercury compound with the water molecule, so that sodium combines with the hydroxide which is present in the water to form a sodium hydroxide, whereas the remaining hydrogen gas will be released and the mercury will be again retained for the next electrolytic process. So this follows out from the decomposer, and sodium hydroxide will be formed which is evaporated to the dryness. So here I have a figure to explain about the manufacturing of sodium hydroxide by Kastner-Keller process. You can see here, this is a long chamber which consists of 2 electrodes, that is graphite black, you can see that. And also here we have another electrode that is known as anode. This is made up of titanium. Okay. So you can see that this is the first chamber where I have placed the brine solution. When you apply the fresh brine to this chamber, when you apply the electrical field, what will happen? Firstly, the chlorine will loses 2 electron and become Cl2. And these 2 electron will be accepted by the sodium atom to form 2 sodium molecule. That chlorine gas, you can see that it will be get evaporated very easily. Later, the sodium, however we got from this chamber, it will be later combines with the mercury to form a amalgam, Again, it will be sent to the chamber called as decomposer. In that chamber, sodium amalgam or sodium with the mercury known as amalgam, it will be treated with the water to form a sodium hydroxide with the evolution of what? Hydrogen gas. So here the sodium hydroxide will be formed, and you can see that it will be separated out. Hydrogen gas which is also get easily out from that chamber. The remaining mercury, what it is there, again it will be pumped back and to combines with the sodium ions with the mercury to form a sodium amalgam. This is how, by using this Kastner-Keller method, we can easily prepare the sodium hydroxide. So hope you are understood with this manufacturing processes. Let's see with the properties of sodium chloride now. Sodium hydroxide is a deliquescent solid, so it absorbs the moisture and the carbon dioxide from the liquid carbonates and from the bicarbonate. That is why we store the sodium carbonate, sodium hydroxide in the airtight bottles. And then coming into the uses, the sodium hydroxide will be mainly used in the following purposes: in the refining of petroleum, in making of paper, in the textile industry, for mesmerizing the cotton fabrics, and also in the printing and dyeing, as well as in the manufacturing soap, because this sodium hydroxide which gives a soapy touch. That is why in the manufacturing of soap also we use this compound, and in the purification of bauxite and in the refining of oils and fats we use this sodium hydroxide. So you would have seen that in the sodium hydroxide, the uses are very plenty. Why is it like that? Because it is another important compound in the chemistry which will be widely used for the other industry to prepare for the, and it will be used as a raw material. Next is sodium bicarbonate. It is also known as sodium hydrogen carbonate. Sodium hydrogen carbonate. Sodium bicarbonate are commonly known as baking soda because it decomposes on heating to generate the bubbles of carbon dioxide. It is a white, colorless and crystalline solid, completely soluble in water but sparingly soluble in ethanol, and it is the mildest of all other sodium alkalis. So in your home also you would have observed with the baking soda, not only in the home as well as in the bakery. So they'll use this baking soda as one of the raw material to cook for the cake as well as for making the idlis at home as well as dosa. For all these processes, we use the baking soda because it will soften the food, especially in the bakery industry to prepare the bread as well as with whatever the things called as, they'll use this baking soda as one of the raw material because it will soften the food. Okay, it is also known as what? Sodium bicarbonate or sodium hydrogen carbonate. So how to prepare this? The sodium bicarbonate is prepared by purified aqueous sodium carbonate solution by passing the carbon dioxide through it. Here you can see the reaction. The sodium carbonate, as we obtained from the solvent processes, we can continue that reaction here. So sodium carbonate, which is allowed to react with the carbon dioxide, it forms what? Sodium bicarbonate. Remember, the bicarbonate will be precipitated out and it will be less soluble and it will be separated and dried and it will be used as baking soda. Next is uses of sodium bicarbonate or sodium hydrogen carbonate used as baking powders or in treating the wool as well as with the silk, used as fire extinguisher, used as mild antiseptic for the skin infection. Especially, if any ants which is bitten on your skin, we suddenly rub with the baking soda. We know that baking soda is a base. When any ants or any insect which is bite on your skin, it will releases the acid. Is it right? Once it releases the acid, if you apply this baking soda, it will neutralize the acid which has been spread in our body. That is why in your home you would have seen that the elders, what they will do, when insects bite on your skin, they suddenly rub your skin with the baking soda because it's a base. It will neutralize the acid and stop the reaction. So hope you all understood with the sodium bicarbonate. Lastly, we will discuss with the biological importance of sodium and potassium. So we all know that sodium and potassium, these two elements are very important for the human body because we know that sodium is itself will be present in blood, whereas the potassium which is also required for our body, especially for protein synthesis. Is it right? Let's look at with an example. Sodium and potassium are essential for all the organisms, and their monopositive ions are structural promoters for the polynucleic acids. For the nucleic acid production, these two elements are very important, and potassium is very important for the enzyme activator and also play a very important role in nerve action and cardiac action. So whatever the nerve actions as well as the cardiac actions which is taking place in our body, this is due to the potassium ion. And the potassium will be required in cell glucose metabolism as well as in a protein synthesis. It has been found that most of the animal, they contains a concentration of sodium ion is 15 times than that of the concentration of potassium ion, which means to say that suppose if you take the blood, we know that in the blood there will be a more concentration of sodium is around 143 millimoles, as it is compared with the concentration of potassium, that is around 5 millimoles. So totally we can say that both sodium and potassium is very important for the human life, especially to prepare the polynucleic acids. And sodium is relatively harmless except in excess production, whereas potassium is moderatively toxic to the mammals where the infection is intravenous, otherwise it is harmless. So this is how we can easily understand that sodium and potassium salts are very important for the human body. So you would have seen that if the person is become very faint or he is become very unhealthy, the first doctor will be suggested to take the electrolyte. The electrolyte which consists of sodium and potassium ion, first it will give energy to us. Is it right? So in the next class, again we are going to continue with the group 2 alkaline earth metal. By this, I like to say that what all the things I have covered in this session, only the important compound that preparation and the uses and the biological importance of sodium and potassium. Have a look on it and make a note. We'll meet you in the next session. Till that, take care, be safe. Thank you.